Hello, this is Robert Casey, and we're going to be looking at the Y-step haplogroup predictor tool for haplogroup R in a different light. We're going to actually be pulling up the Excel spreadsheets, and I'm going to go step by step through Excel, as well as porting a CSV file out of Excel into the statistical tool AcaStat, and it shows you step by step for a very small and easy to understand predictable haplogroup. So I'm now going to show you actual step-by-steps for creating prediction models. The first thing, there's some pre-steps you have to do, such as determining the signature for your predictable haplogroup and creating the formulas for signature match and genetic distance. So if you look at the signature, it's on this line. And how did it's on line 13. That is the signature for BY23537. It's under Z253. So what would cause this signature to be, how do you figure out the signature? You start with the copy of the most common values for L21, which is in row 10, and you copy them down into the signature, and that's your starting point. Then you look at all your positive testers. These are the people who have been confirmed. So the positive testers, in this example, to keep it pretty simple, I'm only going to do a very small predictable haplogroup, so the concepts will be easily viewable. So you look at all the ones in these 5 rows, and you will look for any deviation from the L21 model that's more than 75%. So the first one we were trucking along, and there's 3 12s and 2 11s. Well, that's below 75%. And I marked that in purple so to indicate to me that later on, if a lot more 12s show up, the signature will change and it'll need a new model. But currently it does not satisfy the requirements for inclusion in the model. The next one, or the first one defined, is 39-2, and all 5 are at 14. Now 14 is 2 steps from the L21 model, so that makes it a more unique marker in the signature. So, but it's 100% that value. The next one is only 1, so that makes it 80%. So that will get included because it's greater than 75%. Of course, later on, you could have a truckload of 17s, which would take that below 75%. But for now, we're just using the ones over 75. Then for 449, this is a little bit different because there's 2 values. The way signatures work is you take anything that satisfies the 75% criteria. So at 28, which is more extreme, that's only 3, that's 60%, so it wouldn't qualify. So, but at 29, it includes all 5 testers. So it will be less than equal to 29. And it's always 28 still satisfies because it's a less than. So anything smaller is also included. Then we have the 4th one, which is all 5 16s. And then we have another one, which is a multiple step. And it's at 80, so it could change, but it's currently at 80%, so that get included. And we got 3 more with pretty straightforward. It's undoubtful that they will change, but they could if a lot more data is added. So that's how you determine the signature. So now the signature is now loaded into this line, and you now have that completed. So the next step is create the genetic distance and signature matching levels. So all this is, if you look up very high and I click on them, it'll tell you which ones are in the signature, but you still have to key in the proper less than 14. The second one is less than 16. Third one is less than 29. And so you still have to go in there and code them. These are count ifs. And each count if the count if component is true, it adds one. So if you're missing one, such as down here at 7, let's see which one's missing. You're missing the AR value. So that's the reason it slipped down to a signature match of 7. So all you do is modify this occasionally. Sometimes you add and delete, or if you copy this whole thing to another haplogroup, you have to do a pretty radical change. Now to do genetic distance, you go to the end, and these are the modal values for L21. You copy all those down, and then you update all the values of the signature for this particular haplogroup to get it back up to 65 markers if it's an exact match. Because at 65 markers, it should be 0 in this column. So I have updated it properly. Like X has to be updated to 14. So you go out here again and to show you that it is 14. X all the way here, you got to scroll over to the next screen. X is 14. So that's how you see, you got to modify all 8 markers into the genetic distance to get that to work. And this formula never changes. You just have to change the values out here to the right. And I do this, these are by the panels. There are 6 panels for Y67, and I do it by panels because it's easier to debug. Because a lot of times, you know, it's hard to do it when all 65 are in one big macro. Also, if you have a lot of testers in your database, you can only copy and paste about 20,000, 20 to 25,000, because it's a very RAM intensive, and these are pretty big formulas, and it takes time, and if you don't have a lot of RAM, that could be a problem. So that's it. So we have now done the first step. We've created the actual signature on line 14 line 13 for BY23537. We also created the formulas for the signature and genetic distance from the signature, and we also have created the starting point for all the macros. At this point, once you do that, you just copy all these down to all the testers in your database, and once you do all the panels, then you go back and copy all the signature match and formulas, and that will be the input to AcaStat and to all other to AcaStat, because that's really there only for SNP prediction. So at this point in time, the next step is to go ahead and and take all the data and put it in this AcaStat tab. Right now I need to get rid of everything here. And I'm going to redo all this. So how do you redo it from your source? First of all, the AcaStat does not want your predicted. It wants only confirmed testers and both positive and negative. So you need to sort by the colors in column D, which is a real handy way of doing it. So before, when I did SAP, I wanted the green and blue. But now I want the green and the red to, or magenta, to be on top. So now that's what is needed for the input to. So I'm now ready to import this. I want to always kind of separate this section so I can know when I'm done with the valid data. So now AcaStat only needs three parameters. It needs the 1 and 0. That means it's 100% going to be positive, and that's 0% of being positive. And then you need the values for input the model of signature match and genetic distance to the signature. So I got all that information already calculated. So the next thing I need to do is create input for AcaStat. So I copy all the positives out to this, then I'm going to delete all the stuff I don't want. So I copy all that, paste it, and you need to paste values so all the formulas become integers. And so I want to keep, just for debug purposes, I keep the ID. I'm not going to use it in AcaStat, but it's sometimes helpful for debug purposes. Here's the 2 columns I don't want. Delete those 2 columns. And now I need to put those in the right place. And I clump them there. Now there's one little bugaboo. So this column A1 for CSV files, which we're going to be creating here shortly, cannot start with certain letters. And it depends on which version of Excel that you have. So I highly recommend you put FT and ID. If you put ID in there, the I is a reserved character, and it'll do funky things. And I think A is another reserved character. But FT and ID will work in column A1. That's just a limitation of Excel CSV files. So now I have all this data the way I want. Let's go ahead and save this first just to keep everything in the source file up to date. So now I'm going to create a CSV file. So I do a save as, and I'm just going to overlay that one and make it a comma delimited CSV. It cannot be any other of the CSV types. They will not work. So there is the one, and so now it's going to save just this worksheet. And it's going to delete all the other things. It's just going to save this data. And it's going to save it in a CSV format. So Microsoft Excel gives you lots of warnings. So here comes the save. So the first thing says this file type, which is CSV, does not support workbooks. So it says it's going to clear out everything except AcaStat. Yeah, we know that. That's the purpose, to get it into AcaStat. Second thing, it's going to say, oh, you may have some features that you're going to lose. Well, when I do a copy and paste values only, I left out all the formatting. And so what this is saying, it's going to remove all the formatting. Yeah, that's okay. And at this point in time, it should have saved it. And now we're going to go back. I want to save this again under E, just to make sure that it's saving it. So same issue there, formatting issue, and if you look at the control panel for it now has CSV, so it saved it. So we're done. So let's exit this file. Now, if for some reason it always asks you, and this will change depending on what flavor of Excel you have, but you don't want to save it again because it's already saved once. We verified that. So there it is, saved. So now we're ready for the next step, which was to be to take this CSV file that we created, and we can go ahead and pull up the CSV file. You can look at it just to see what it looks like. And all it is the data that we wanted. So it worked. So now we've created the input to AcaStat, and I've launched AcaStat. But now let's figure out the few short steps that are required, and it's not very many. So the first thing you do is you import the file, the CSV file. There, and open, it's loaded. So now I have loaded the input file to AcaStat. Next, I have to slide the slider bar down, click one up, and pick regression log. That's the model I'm going to be using. That's binary logistic regression. So that's step 2, loaded the data, chose the model. Next, I have to assign the variables. Dependent is the output results. That's 1 or 0 or between 1 and 0. And signature and GD are the inputs. Now assign the variables. Now calculate the model. It's done. So I want a little more information on that, so I go to the output log, and I want to save all these coefficients in this nice little table. So I copy that, and then I will paste that into the Excel spreadsheet, and that's it. That's all it was required in AcaStat. So the next step, I would say, I pulled up Excel again, so this recording can find it's using Excel, but I can still go to AcaStat, copy that, and paste it into this tab. Now, this now has all the input for this model. It also has the output for the model. And this model has now changed since we added a few of those zeros down there, if you didn't notice. And so what we need to do, I need to write down the coefficients, which are in 2 different places. They're here and they're here. So you need 4 digits to the right. So the first one is negative 237832. Second variable is positive 85167. And the last one is minus BY23537. So we no longer need AcaStat because I've copied all the output that I want, and it only takes 1 or 2 minutes to generate it again. So, and you probably want to do it again because if you get anything that's slightly higher genetic distance or slightly lower signature matches, it'll change the model. So, at this point in time, I have what the current input to the model was and what the output is, and that's all I need. So the next thing we need to do, we need to go and put this into the actual model. And here's the value for that model. And this was the previous one, but now since we added a few more zeros, it changed slightly, which really surprises me that it changed so radically with such minimal change. So put -23, 7832, and now it's still +8, but now it's 5167, and it's still -4, but it's 2647. Now, the constants appear twice in the numerator, which you've already entered, and I'm just going to copy everything within the parentheses and put it in the denominator. You could just re-enter them again, but that means it's subject to potentially, finger fudges, so we don't want to do that. So I'm going to take the color off this. No color. Then I'm going to copy the new formula down through the whole spreadsheet. And so we're going to analyze to see how, make sure that this has 100% accuracy as the model showed. So all the ones are positive, there's 5 positive ones, so that looks good. So I'm going to mark those all. I'm going to go back here, and let's go ahead and delete all these colors so I can re-enter them again. And it didn't take for some reason. No color. Okay. Okay, so now there's no colors. So we know that the first 5, which are the green, confirmed ones, or confirmed by the model, because they're all ones on the right side. So I'm just moving this over so I can have all the data convenient over on this side. So I go back over to the left and see how many are zeros. Those are all zeros. Those are all zeros. Oops, nope. Let's just go down to here and do those zeros. And so those are all negatives. So you get rid, I need to delete all the text in this row, because the way I copied it last time, you put a random variable in there. You don't want to have stuff, because if you sort it now, Excel gets lost. So all these are zeros from all the way down to 40, which should be, they're all the ones that we had inputted to the model. So that's correct. So we now have this ported over to the left side of the spreadsheet. And then the next one, this is the interesting stuff, okay? These are the YSD-early ones that we haven't looked at yet. And it says the first 6 are all ones. So we're going to mark those as green. and we're going to go with those. And I've already color coded them as blue previously, just to make them easier to keep track of. And boom, those are green. It means they're positive. So the model didn't change. And we go over here. Now there is a little teeny bit of match on that, but that's not greater than 0.5, so it's considered negative. So we're just going to go on down and verify everything is negative. Yes, it is all negative. Here we're going to update it to magenta to indicate it was, and we're going to transfer all this over to this screen and mark that. And we're basically done with the porting of, we've done two things. We've actually entered the model back. The model is, way far over here. So the model has been input. It's been replicated to all the testers in the database. And then we copied and pasted all the over to the left side so we can kind of verify, yes, all the ones that are confirmed to be DF 23537 positive. They've all been predicted, and all the negative ones, which start with 6, which is pretty close, but not close enough for the model to not catch. And then they've been all confirmed. And the new piece of news is we now have 6 new testers that are YSTR only, and they are all predicted to be BY23537. That's the whole purpose of prediction, is to find these 6 testers and to make the guesswork of who belongs and who does not belong. So that's it. Appreciate you listening. And if you have any feedback, please go to my website and send me an email, or I post on Facebook forums a lot, so you can catch me there. And I'll be posting this to YouTube. So thanks for your attention.